Okay, here's another question about cooling. Okay, we get these quite often. We've got an investigation into how the surface area of hot water exposed to the air affects the decrease in temperature of hot water. So a very simple cooling experiment. We've got a procedure. As ever, I hope you've tried the question. I'm going to crack on with a little discussion of the answers as we go. So here's our steps. All right, now you notice here, there's a lot to read. You don't have to read it all, okay? If you are, especially, I know that a lot of English as second language or additional language students really struggle with this part. You don't have to sit there and understand everything here. Obviously, it'd be great if you did, but I know that it's a challenge. It's a lot of text. Take a second, read the steps maybe, but if you're not really sure, just crack on, okay? Because you still can do some stuff. First thing we're going to do is look at our tables of results, okay? And it's not actually been asked yet, but we're going to fill this in. You can see that we've got the surface area, temperature 1, temperature 2. Temperature 1 is always the same, control variable. Temperature 2 is changing, and we're going to get the decrease. So you can see there, okay, how we're calculating this. We're going 95, take away 92 is 3. Even without doing the question, you could fill in this because you know that you've got to fill in a table, etc. Okay? So, first thing, does it even ask, I'm just checking, does it even ask us to do it? No, it doesn't. Okay, first thing we're going to do here, it tells us that we're going to measure the diameter. Okay, we know the diameter, sorry. We're going to calculate the area, okay? We are using an equation which is given to us, and all we're going to have to do is make sure we calculate it to two significant figures. So we've got 0.785 and 9.3. When I put that into my calculator, I got 67.89, and then took that to three significant figures, 67.9, another one, 68. Okay, so that's our first point in our table. You noticed in the table I filled it in to be 68 there, to two significant figures. Okay, 1 mark for the correct working, 1 mark for writing to two significant figures there. We're then going to fill in our temperatures. Okay, we're going to record them to the nearest 0.5. Now again, only real problem here, I think most people are fine with them. We're going to go up here, we're going to go 91, 92, 93. It's between 93 and 94, so that's 93.5. In this case, it is bang on the 7th, and so therefore you'd be tempted just to write 87. But it's not 87, it's 87.0. That point is really important because it's telling us it's not 87.5 or 86.5, it is 87.0. Okay, so we're going to put those temperatures in, and we're going to calculate the decrease in temperature. Decrease in temperature is just the original temperature, 95, minus the values we've given here. Okay, nice and simple so far. Now, this is where I'm really glad we're going to have the chance to do this question, because we're being asked to describe in detail. Now, I've said in previous questions, a lot of students are tempted to talk about proportionality, etc. Okay, this is where you can talk about proportionality, or you can at least get into a bit more depth. Now, what you'll have noticed in the question is that as area increases, the decrease in temperature also increases. Okay, so we've got increased area, increased change in temperature. I don't like using the word decrease here because we've got decrease and increase. It can get quite confusing. Okay, the change is increasing. And to give a bit more detail, what you could say is, well, okay, let's look at the ratio. Okay, in the first case, I've got a change of 1.5, and I've got an area of 11. In a later case, I had a change of 51.5 and an area of 68. You're noticing here that the ratio of the values is not the same. Okay, now that is suggesting that it's not directly proportional or inversely proportional. There's something else going on here, but we have a different rate in decrease. Okay, so notice here the difference here between describe and describe in detail. If it's in detail, you have to go into more detail. You have to give some more information. In this case, I've used the ratio of the two of the numbers because it just sort of shows that I'm thinking about whether it's linear or not linear. Okay, a more functional step asks us to explain why it's important that the student stirs the hot water. Well, it's to make sure that we've got an even distribution of the temperature. In other words, that we're measuring the average temperature. If you didn't stir it, you could have hot areas and cold areas, and that would mean you'd be measuring not the average temperature, but the temperature of just one part of the water. Okay. Then we move down the beaker and the thermometer for the final experiment shown here. The student repeats the procedure using a beaker with a larger diameter. Okay, suggest why the temperature is not accurate. Well, if you look here, we're at the point where our bulb, this little bottom bit of the thermometer, is poking almost out of the top of the water. Okay, if we were to go any bigger, then the bulb would start pointing out. Actually, the bulb would not be fully submerged in the water. Okay, so therefore our temperature is not going to be accurate because it's not measuring the temperature of the water, it's measuring the temperature of the air as well. Okay, then we've got this point here. Oh, ignore the bell. For those of you who are at school, we're going to have a few flashbacks there. Okay, we're going to work through it, folks, just like you were doing a lesson. Should really have a little song here. Okay. The student says the procedure in A is not valid. Okay, they repeat the procedure in A and insulate the sides of the beakers. And we want to know why this makes the procedure more valid. Well, in our experiment, we're trying to find out the effect of area, but specifically the top, the cross section. But as we change the size of the beaker or the volume of the water, etc., we're going to get heat loss through the sides of the beaker. Okay, insulating the beaker will remove the effect of the heat loss and allow us simply to find out the effect of heat loss due to the surface area. So the insulation reduces the heat loss to the surroundings, and that's going to change as the area changes. It's going to be a non-constant variable, a not controlled variable as we change that area. Okay, so we need to insulate them to remove that, or essentially to make sure that we're looking at our heat loss through the sides as a controlled variable. Okay. All right, last one here. The rate of cooling of hot water increases when the temperature difference between the hot water and the room increases. Okay, we're going to repeat it in a warmer room. Okay. All right, and we want to know what the value of T2 is, okay, in the experiment. So in other words, if I did the experiment in a hotter room, what would happen to the final temperature after a certain time? Okay, well in this case, it's going to be larger, okay, because we've got a smaller temperature difference between our two substances. Okay, we've got a hot substance and a cold substance. In other words, the room. If you've got a hotter room, then you're going to have a lower temperature difference and therefore a larger final temperature.